All right, I want to walk you through the circle of Willis, which is a bunch of arteries in the brain that connect to each other to ensure that the brain has sufficient blood supply no matter what. So even if we look here at this blood vessel, you see these lighter color portions, that's actually fatty plaque forming in this vessel. So if an occlusion was actually to happen here and blood could not travel to the brain, then all these arteries are attached to ensure that sufficient blood supply gets to the brain, because obviously it's a very important organ. So the connection of all of these arteries is called an anastomosis. So if you hear me say that, that's what I mean, connection of arteries. So the main suppliers to the circle of Willis are the vertebral arteries, which you can see right here, traveling up the medulla and part of the spinal cord here. And these join together to form the basilar artery, which is the main blood vessel traveling right here atop, or technically beneath, the pons, which is the structure that I'm touching here. The other main contributor to the circle of Willis are the internal carotid arteries, which are right here and right here. Now, to remove the brain from the skull, these internal carotid arteries had to be cut right here, so there's just little nubs left, but they would be traveling as my probe is and inserting as such. So these are the internal carotid arteries. So if we take a look at the circle of Willis, it really just forms a circle here around the optic chiasm here, which is the joining of the two optic nerves coming from the eyeballs. So let's take a look posterior to that. We can see the posterior communicating artery right here and right here on both sides. And branching off of that, we can see the posterior cerebral artery right here. Move that nerve out of the way. We can see it on the other side as well, right here. And then as we continue down, we see the superior cerebellar artery, which is part of the circle of Willis. We can also see the anterior inferior cerebellar artery on both sides. And if we go down a little further, we can see the posterior inferior cerebellar artery that I'm holding right here. So these, obviously the cerebellar named ones go to the cerebellum. The posterior cerebral artery, which I'm holding here, goes to the posterior cerebrum, which is the main part of the brain that's not the cerebellum. And then those all connect to the basilar artery either directly or via the posterior communicating artery. And the posterior communicating artery attaches to the internal carotid arteries here, and branching off of the internal carotid arteries, we can find the middle cerebral artery here on this side and here on this side. Now I'm gonna reflect the eyes back so that we can see the anterior portion of the circle of Willis a little bit better. But then this, you can see this forms the circle here. And up here, we have our anterior communicating artery, which branches then off the anterior cerebral artery. So we have an anterior cerebral artery, a middle cerebral artery, and a posterior cerebral artery, all attached in this circle of vessels. So no matter what, our brain's getting sufficient blood supply for us to live and survive. It's pretty cool.